The percent of fat calories that a person in America consumes each day is normally distributed with a mean of about 32 and a standard deviation of about 11. So this is a two-part problem. We're doing the same thing in both parts, except for the first part, we're doing it with one individual. Suppose one individual is randomly chosen. Okay. For the second part, we're doing it with a sample of 25 individuals. Suppose that 25 individuals are randomly chosen. This is going to change what our distribution looks like. Okay. So let's do the first case. Really, this first case is exactly what we were doing in section 4.2. When we were just finding the probability of a generalized normal distribution. Okay, so we are told that the population is normally distributed. Okay. Mean of 32, standard deviation of 11. So when we're looking at what distribution we will use, since we're only talking about one individual, we just use the data they give us. 32 is the mean, and 11 is the standard deviation. So mu, and we're going to specify, since in part 2 we're going to have a different mean and standard deviation for our collection of samples. So mu for a member of the population, so we usually use x, is 32. And the standard deviation of the distribution of the population is 11. Okay? So let's put that in to our notebook. So 32 and 11. Blow that up a little bit, make it a little easier to see. Okay. So next part. We want to list the z-score needed to calculate the results. Okay, so to get to the z-score, we're going to use the same formula we've been using. Okay, we're going to say z equals x minus mu over sigma. So to find the z-score, given a value in the distribution, you just take the value minus the mean of the distribution over the standard deviation. So in this case, it's the mean of our population distribution, the standard deviation of our population distribution. So it's the 32 and the 11. So in this case, we want to find the probability that the individual normally consumes between 28 and 37 fat calories per day. So we're looking for, so say this is 28, this is 37. We want to know this area here. In math, that means we want the probability that x is between 28 and 37. Okay? So we are going to need a z-score for both of these. Okay? So z1, our first z, and I'm going to plug in our first x. Let's call 28 our x1, our first x, and we'll call 37 our second x. So our first x, that's going to be 28 minus the mu, the mean of the population, 32, over the population standard deviation sigma x, which is 11. Okay, and z2 is going to be x2 minus the mean of the population over the standard deviation of the population. So that's going to be 37 minus 32 over 11. So let's go to the notebook and calculate both those out. So z1 is going to be, let's see what we got here, 28 minus 32 over 11. So remember those parentheses, 28 minus 32, that's what goes on top, divided by 11. Okay, and let's have that print out, and then Z2 will be, and that's going to be 37 minus 32 divided by 11. So parentheses 37 minus 32 divided by 11. And let's make sure we can see that too. So run that. Just loading up here. There we go. We have our two z-scores, okay? So in my open math, list the z-scored needed to calculate the result. That's what we put in here. So we have our first z-score, comma, our second z-score, since we have two z-scores here. Okay? So I got them both in there. Now, what this means is that since I want the probability that x is between 28 and 37, that's equal to the probability that x is between, and what do we have here? We have our two z's are negative 0.3636 about and 4545. So negative 0.3636 is less than z is less than 0.4545. Okay, so we just converted from our generalized normal distribution to a standard normal distribution. Now that we have the z-score, we're going to find the actual chance. There is a blank chance that the individual normally consumes between 28 and 37 calories per day. So to find that, we're going to use the p-norm function, and we are going to, let me go over here to give us some room. So we want, so now we have a standard normal distribution with mean 0, and we want between negative 0.3636 and 4545, so something like this. So we want this. When we calculate the in-between, we're going to take everything to the left of the bigger number. Okay, so that's p-norm and lower tail true because we would be including the lower tail. We're taking everything there. But notice that's too much, right? We only want this blue region. So I need to take away the excess. So I'm going to be subtracting everything to the left of negative 0.3636. So all of this I don't want. So I'll take the green and subtract the red, and that gets me the blue right here in the middle. Okay, so green minus the red equals the blue. Okay, so let's put that into our notebook. Need a code cell for that. So P norm, Q equals, so my bigger Z value, so that's the 0.4545, which I stored in Z2, so I don't have to type it again if I stored it. Lower tail true. And then that's going to give me everything lower than that 0.4545, the probability of everything lower than that 0.4545, but that's too much, right? So I'm going to subtract the excess, which is everything to the left or everything lower than that negative 0.3636, which is my Z1. So run that, and there's my probability. Okay, there it is. So the way we'd interpret that is there is and that's about a 31.21, sorry, no, 72, 31.72% chance that a randomly chosen, what are we talking about here? Randomly chosen American consumes between 28 and 37 fat calories per day. Okay, that's what that means. So let's take that decimal probability. We'll stick that in here, and that's what's there is a 0.3172 chance that the individual normally consumes between 28 and 37 calories per day. Okay? So that's if we're looking at just one individual. Part two, we're going to do something a little different. We're going to look at the full sample. Okay? Suppose that 25 individuals are randomly chosen. I can go back here for this. Part two. Suppose that 25 individuals are randomly chosen. Find the probability that they normally consume an average of between 28 and 37 calories per day. So there's a couple things that we're looking at. We're not looking at just one individual. We're looking at a sample of 25 individuals. And we're looking at the average of those 25 individuals. Okay? So the observation here, and I'm going to erase all this. The observation here is that we are going to be using the central limit theorem. The central limit theorem tells us, oops. Okay, there we go. The central limit theorem tells us that if we have a distribution, the samples of that distribution, a sample of a given size, if we look at all the ways to sample 25 individuals in the population, that all the averages of all those samples are normally distributed. So we will also have a normal distribution in this case. But now, instead of looking at x, we're looking at the sample, x bar, of the mean of the sample, mean x bar of the sample. Okay, and so we are going to need a mean that corresponds to that sample. In this case, the central limit theorem tells us that the mean of all samples, of all sample averages, is the same as the mean of the population originally. So that's going to be 32 still. So when we're looking at the distribution, we still have a mean of 32 here. Okay, but according to the central limit theorem, the standard deviation of the distribution of sample means is not just the standard deviation of the population, okay, but it's the standard deviation of the population divided by the square root of the sample size. In our case, the standard deviation of the population is 11, and we have a sample of 25 individuals, so square root of 25. Okay, so to find the standard deviation of the distribution of sample means, we got to plug this into our notebook. Okay. So whoops, that's not where I want that. There we go. So we're going to take 11, the population standard deviation, divided by the square root of 25, the sample size. And that gives us the standard deviation of all sample means where the samples are of size 25. In this case, we get 2.2. So that 2.2, that's what goes here. So we have 32 here, and then 2.2 here, because we're looking at the sample of 25 individuals and not just a single individual anymore. Okay? Okay, z-scores. We're going to calculate the z-scores the same way, except now we're going to use this mean, this standard deviation. Okay? So we still want to find, ultimately, the probability that we consume between 28 and 37 calories per day. So we are still looking for probability that we consume between 28 and 37 calories per day. But now we're not looking to see if one individual chosen consumes between that much, but if the average of the 25 people chosen is between those numbers. Okay, so again, we'll need z-scores for each one of these. So again, I'll call this x1 bar and x2 bar. okay? The z-scores we're going to use the same formula. Okay, it's always the value minus the mean over the standard deviation. But now the values are sample averages. And so we want the mean and standard deviation of those sample averages. So for x1, our first z is going to be x1 bar minus mu x bar over sigma x bar. So that's going to be 28 minus 32 divided by, and remember here for our sigma x bar, our standard deviation of sample means, we got 2.2. So instead of dividing by 11, we're dividing by 2.2. Okay, and that's using the central limit theorem. And z2 is going to be x2 bar minus mu x bar over sigma x bar. And that's going to be 37 minus 32 over 2.2. So let's take those, let's plug them into our notebook and see what we get. So z1 in this case is 28 minus 32 divided by 2.2. Let's print that out so we'll be able to see it. And then z2 is 37 minus 32 divided by 2.2. Print that out so we can see it. Okay. Notice these z-scores are different from the z-scores we got before. So let's copy them, let's paste them in here so we can get our answer. Okay, so those are our two z-scores separated with a comma. Okay, finally we need the probability. We're going to calculate the same probability, the same way we did before. Okay, we're going to take the higher z-score and then subtract the probability that we're left of the lower z-score. So p-norm, so the higher z-score is our z2, right? z2 is the 2.2727. So z2, and I want everything to the left of that. And then I'm going to subtract the probability of the lower z-score, and I want everything to the left of that. So I'm taking everything to the left of my bigger z-score, but then that's too much. So I subtract off the excess, which is everything to the left of the smaller z-score. Okay? There is a 95.40% chance that a sample of 25 individuals will have an average fat calorie intake of between 28 and 37 calories daily. So notice how this differs from what we did before. Before we were just saying, what's the chance of finding one individual between these values? Now we're saying, what's the chance of getting a sample of 25 individuals and having that average being between 28 and 37 calories? Okay, so let's take this. Okay, so there is a 0.95396 chance that 25 individuals, normally consume an average of between 28 and 37 calories per day. Let's click it. We have it. Okay. Do notice the difference in the probabilities here. Okay. And this, so the probability of selecting one individual and having it be between those is only 31.72%. But the chance of having those 25 individuals be between 28 and 37 is much higher, 95.39%, right? It's a much higher probability. And the reason the reason for that is we're not looking at just one individual. If you look at just one individual, there's a good chance or a decent chance that you will have some more extreme value, right? But if you look at 25 individuals, you might have some extreme highs and you might have some extreme lows, but they will tend to cancel each other out. And so you're more likely to be closer to the mean. Okay, so I hope that makes sense.